So here we have a curve, 3 roots of x on the x-axis, and we have a line of x is equal to 10. So that would be a vertical line right here. And it's saying I would like to find this area right here between 0 and 10. And the other day, you guys went about this, didn't you? And you constructed all sorts of shapes, didn't you? Okay. And we're going to do one example right here. And what we're going to do is we're going to do some different sums. We're going to do the right-hand sum of 2 rectangles. Okay? I'm going to create 2 rectangles in here. If I create 2 rectangles, what's going to be the width of each rectangle? 5. You can see that this would be the first rectangle, and this would be the second rectangle. Does that overestimate the area or underestimate the area? Yeah, it overestimates it by quite a bit, doesn't it? I want you to think about as we do this right-hand sum of 2 rectangles, I want you to consider the actual operations that we're using. We take 5 times the height. How do you determine the height? It's f of x. I would take what and plug it into the function? 5, and you would get 3 roots of 5. Does everybody agree? So I would take 5 times 3 roots of 5. Stop it. Plus 5 times, what do I plug in next? 3 roots of 10. And if we were to take our calculator, go ahead and take out your calculator. You're going to need that today a bunch. Five times 3 roots of 5 plus 5 times 3 roots of 10. And I get 80.975. Everybody agreed? Okay, that would be the right-hand sum of 2 rectangles. I'm going to do another one. Okay, I'm going to do a right-hand sum of 5 rectangles. So if I do a right-hand sum of 5 rectangles, what's going to be the width of each one? 2. 2 is going to be the width of each one. Overestimation or underestimation? It's an overestimation. Is it better than the last one? Yeah, it's better than the last one, but still definitely an overestimation, isn't it? I'm going to take a slightly different approach here. Okay, I'm going to take a slightly different approach. Do you agree that the width is the same for every rectangle? So I could factor the width out. Look at your previous problem. It's 5 times 3 roots of 5, then it's 5 times 3 roots of 10. So I'm just going to factor the width out. So it ends up being the width, which is 2 times the sum of all the heights. 2 times the sum of all the heights. What will you plug in to get your first height? Yeah, you'll plug in 2, and you get 3 roots of 2. What do you plug in to get your next height? Yep, 3 roots of 4. What do you plug in to get your next height? You got 3 roots of 6, 3 roots of 8, and 3 roots of 10. Is everybody okay with the fact that I factored the 2 out to the front? Does that make it a little bit easier for you? So it ends up being the width times the sum of the heights. So we took that little bit here and bring it over here. And should we get a value that's more than 80 or less than 80? We would expect less than 80, so I got 2 times parentheses, 3 roots of 2. Hey, don't do that. What's going on? 3 roots of 2 plus 6 plus 3 roots of 6 plus 3 roots of 8 plus 3 roots of 10. And lo and behold, I got 71.126. Ooh, I got less. Didn't I? I would like to do one more, and then I'm going to show you how to get an exact number based off your calculator. I would like to do 10. If I do 10 rectangles, what's going to be the width of each rectangle? The width of each rectangle is going to be 1. Is it an overestimation or an underestimation? Still an overestimation. Is it better than the last one or worse than the last one? It's better. Huh. Something really interesting going on here. I hope you guys can consider this, because it's where we get this term calculus from. What is happening to the number of rectangles that we're creating? It's increasing. So suppose we wanted a perfect, exact value. How many rectangles would we have to create? An infinite number of rectangles. So the limit of the number of rectangles, we're pushing towards infinity. Tell me what's happening to the width of each rectangle. So the number of rectangles is going towards infinity. The width of each rectangle is going towards 0. See that? The word calculus means the ability to calculate the infinitely large and the infinitely small. And that's what we're doing right now in a very kind of basic way, but we'll still give it a shot. So I have 1 times, and I plug in 3 roots of 1, 3 roots of 2, 3 roots of 3, 3 roots of 4, 3 roots of 5, 3 roots of 6, 3 roots of 7, 3 roots of 8, 3 roots of 9, 3 roots of 10. In fact, as I type it in my calculator, I can make it easier on myself by factoring out what? I could factor out a 3, and that would make it even easier as I type it in. So that means we have a 3 out front times the square root of 1 plus the square root of 2 plus the square root of 3 plus the square root of 4 plus the square root of 5 square root of 6 whoop, messed that up, Mr. Gens. Square root of 7 square root of 8 square root of 9 square root of 10. I'm going to check my work just to make sure I got parentheses around everything, because I want to make sure I don't end up with a complex radical here. And it looks like I'm good. And 67.40. Ooh, look at that. I went from 80.9 down to 71.1 down to 67.4. 67.4 looks like a pretty reasonable number, wouldn't it? So let's not do it, but pretend like we did. If you wanted to get a more exact value, what would you change R sub n to? You would be R sub 20 or R sub 40 or R sub 100 or something like that. Okay? And we would get more and more exact. In fact, R sub 1 or R sub infinity is really what we want to do, right? I mean, that's what we would want to do. Now, I'm going to show you this, and your immediate reaction is going to be like, well, why can't we just do that? Let's just do that all the time. Trust me, you guys, the AP Calculus exam is not going to allow you to do this all the time. You need to understand where we get these rectangles and these estimations from, because they occur in the real world. It's not like everybody who does calculus automatically goes to this function. But if you go to y equals, type this in, and what is our function? 3 roots of x. Type that in. Go to Zoom Standard. Get this nice viewing window. Make sure you've got that square root function. The calculator just died, folks. YouTube Nation, we got a casualty here. All right. Are you ready? Second, calculate. If I choose number 1, what will that give me? the height of the function at any given x value. What will 2 give me? Where it crosses the x-axis. 3 gives me minimum, 4 gives me maximum, 5 tells me intersection point. What does 6 give me? The derivative. 7, this crazy thing gives me the area. This is called an integral symbol. And if you press number 7, it asks you what your lower limit is. We want to start at 0, enter, and we're going to go to what's our upper limit? 10, and watch it. $63.245. What do you think? It's kind of fun. Now it was really cool, and I really love this. Kenzie the other day, she was kind of doing her project stuff. She's like, well, how do I do this? And so what she did is she turned on the shade below button like this, and she looked at the graph, and she's like, well, Mr. Gens, I want it to do that, except I don't want it below there. So she changed her window so that the X minimum was 0. She said, this is what I want. Whoop, I did X minimum 0. Sorry. Window Y minimum be 0. So like, Mr. Gens, I know that the shaded region right there, that's what I want. How do I actually tell the calculator to come up with it? And so she had a good picture and good idea. And it kind of even almost looks like you got a bunch of rectangles in there, right? But ultimately, it didn't give her the best value. But, she was very good to try. So flip it over. Let's practice these rectangle stuff. Area problem, very simple. If you have a function, bounded from A to B. What is this area? We know how to find area of rectangles. We know how to find area of triangles, trapezoids, circles, all sorts of things. But we don't have any formula that says, oh yeah, any function that you got, here's what you do, and you find the area beneath it. I should say geometry didn't produce any formulas like that for you. Calculus does, which is really cool. And so we'll look at the basic example. I'll do the first part, you guys do the next 2 parts. It says find the area bounded beneath the curve y equals x squared, the x-axis, and the line x equals 4 by constructing 2, 4, and 8 rectangles. So you're going to be able to have to construct a function, x squared. This is bounded by the x-axis, which is right down here, and the line x equals 4, which is right here. And I'm going to create 2 rectangles. Everything you do today will be right hand. Tomorrow we'll teach you left hand and trapezoidal and stuff like that. But everything's right hand today. So if I'm focusing on the right hand, okay, and I have 2 rectangles, what's going to be the width? The width is going to be 2. So you learned from our previous example that if the widths are all the same, you can simply take the width times the sum of the heights. There's my picture representing it. Is it an overestimation or an underestimation? It is an overestimation. Okay? No. I'll show you later on. Okay. All right. So I have overestimation. Okay. I have 2 times something. What is my first height? 2 squared, which is 4, plus 16. So I get 40. And we said that that's an overestimation. Agreed? You go ahead. You do 4 rectangles. You do 8 rectangles. See what you come up with. Go. Try on your own. Okay, as you're doing your working, hopefully you come up with, in this situation, we have 1 times the 1 plus 4 plus 9 plus 16, which, what do we get, 30? And then here you have to square 1 half, square 1, square 3 halves, square 2, square 5 halves, so on and so forth. We got an estimation here, 25.5. And if you would like to see if you're on the right track, what you can simply do is, and actually I'll show you something cool. Are you ready? Are you ready? So I'm going to just look at the problem. I'm going to look at it, and I see it, and I got, let's see, we're going to 4. Got it. 64 over 3, which is 21.33 repeating, okay? I bet that when we do the second calculate, that's what you're going to get. I'll teach you to just look at it, and you'll be able to determine exactly the area. I go to y equals. I type in x squared. I get rid of this guy, going back to I do second calculate, and I'm going to do number 7. Lower limit is 0, upper limit is 4, and I get 0.1.3 repeating. Gandalf. I'm Gandalf. Thank you. All right, flip it over. What's different about example number 2? I can't tell you that right now. We got a lot of work to do. Oh, then it's not. Thank you. You're entitled to your own opinion. It's a free country. Most people would disagree with you, but whatever. Yeah. All these. Yep. All 3 of them. Yep. Yep. What's different about number 2? Yeah, I don't give you a graph. You're given these function values, but you don't get to see what the graph looks like. But you have to determine the area bounded by the function using 2, 4, and 8 rectangles. 2, 4, and 8. So the interval goes from -2 all the way to 6. -2 all the way to 6. So what is that width of the entire interval? 8. So if I'm looking at 2 rectangles, what's then the width of each rectangle going to be? 4. So the width of each rectangle is 4. What I have to do is then evaluate the heights. So we're going to break this interval up into 2 rectangles. So a width of 4, so I'm going to go from -2 to what? -2 to 2. That'll be 1 rectangle. And then the second rectangle will go from 2 to 6. And remember, what we decided to do was we were going to evaluate the heights on the right side. So which x value do I evaluate the first height at? Do I evaluate it at 2. And what's the height at 2? 7. In my second rectangle, I evaluate the height at 6. And what is the height? 6. Grace, you have a question. So we have our rectangle, and we are choosing the right side of the rectangle. So this first rectangle goes from -2 to 2. So the right side of the rectangle is 2, and the height at 2 is 7. So I get 7 plus 6 is 13 times 4 is 52. So if I went to 4 rectangles, what would be the width of each rectangle? It would be 2. Well, that means I got to go from -2 to 0, and from 0 to 2, and from 2 to 4, and from 4 to 6. Because the width of each rectangle is 2. Look at my interval. Look at my interval. I go from 6 to -2, so it has a total width of 8, right? Total width of the entire interval is 8. I'm dividing it up into 4 rectangles, which gives me 2 for a width. You blanked out. Are you okay? Back with us? Concussion testing. Concussion protocol. We just like to have a concussion protocol in other sports. We could do it for calculus. Yeah. Oh, just like the material is so challenging that boom, knocked in a concussion state. Okay, so where do I evaluate the first height? And I get second height is at, and I get, then the next height is at 4, and I get 8 and 6. So I've got, let's see, it's 16, 2, so 22 times 2 is, I got 44. Is that what you got? Okay, you try next one on your own. Yeah, so, you know, this is the other functions we've looked at before have been kind of really nice behaving functions, right? But look at this function. This function's crazy. It goes from 5 up to 10, then down to 1, back up to 5, 7, then 16, then 8, then 5, then 6. Like, I mean, this function looks really weird. So who knows? So as we increase the number of rectangles, it's definitely going to get closer to the actual value, but those first few choices won't necessarily always bounce together. Okay, it might get one that's too high, one that's too low, and might go back and forth a little bit. But eventually, as we go to infinity, then we'll get the exact value. No function there, so it's impossible to calculate the exact value. This is our last one for the day. Then you guys can start on your worksheet. It says use the following graph. Sorry. To determine an approximate area bounded beneath the function over the interval 0 to 8 using 2, 4, and 8 rectangles. So now we don't have specific values. We need to do an estimation here. That's what we have to do. So if we were to use 2 rectangles, what's the width of, it says to go from 0 to 8. So if I have 2 rectangles, what's the width of each rectangle? 4. So I have 4 times. Now I'm going to construct my 2 rectangles. Got my first one here. And then I've got my second one. So do you think it's an overestimation or an underestimation? It sure looks like an underestimation here, doesn't it? So the others were over. Right hand does not always mean over or under. But if the function's increasing, then right hand will make it overestimation. If the function is decreasing, then right hand will make it under. Opposite for left-handed, and we'll get to left-handed tomorrow. So, estimate the first height. What do you got for the first height? Sure, we'll go 9. How about the next height? 4, sure. Whatever you want. 9 times 4, 13 times 4 is 52. Okay, I'll do the next one, 4 rectangles. So the width of each rectangle would be 2. And so let's see, I'm here at 2, and draw this rectangle over. 4, draw this rectangle over. 6, draw this rectangle over. And then 8, draw this rectangle. Over or underestimation, what do you think? It still looks like it's probably an underestimation. It looks like a lot better than the previous one, though. How would you estimate the first height? Second height? Third height? I'll go 7. I'll go back to 4. So I get 9 plus 9 is 18. And 18 plus 11 is 29. And 2 times 29 is 58. And we said it's an underestimation, so you can see that the values are now getting bigger. And the last one we would have to do would be 8 rectangles. What's going to be the width of each rectangle if we do 8? 1. So if we simply just add up the heights, we'll be good to go. But I am going to draw it so I can see clearly what kind of estimation I'm getting. And if I ask you these questions on the test, obviously people could come up with different values. But, you know, you got to be within reason. If you break down 34, it's probably not close enough. I hear all these tired yawns. You guys just had 5 days off. But sleep begets sleep, right? So the more sleep we get, the more we want it. So I'm gonna lump all these first 4 together. I'm gonna say they're all about 9. So I'm just gonna say 9 plus 9 plus 9 plus 9. And then I would say that the next one drops down to 7. And then I'm gonna go down to, oh, what are you guys feeling? Okay, so you want to go 8 first, and then 7? And then 5, then 4? All right. So we got 36, and then 15 makes 51, and then 9 makes 60. And we said that we should hopefully slowly increase, and surely we are. So yeah. You got 61? I would accept that as an answer. Good job. Well, probably 64. We all good? Okay, so that's the basic introduction to area. I want you to know that tomorrow we'll be looking at other stuff. And then on Friday, we begin, well, I don't know. It would probably take us 2 days to get through that. Monday next week, we start, it's amazing. You will add up the area of an infinite number of rectangles. By hand, you will compute the area of an infinite number of rectangles. By hand. Your mind will explode. There will be brain matter everywhere. We will take a concussion test before and after and see the results. I'm sure you're going to do great.